I hope my volume is, my voice is clear. My voice is clear? Tell me. My voice is clear, yes or no? Good evening. Okay. So, let us start today's session, that is a milling operation. Okay. Wow, before the starting of this session I got one dislike. I mean, a person is already prepared that before starting the session I am going to dislike the video. Dislike this session. I mean, he has no any work. He has no any work. Either he is a puppet of someone else. Okay. Now, today is the session that we are going to discuss about milling, right? Look, in milling there will be a straightforward question, very simple type of question generally comes, right? In milling, generally very straightforward, very simple type of question will be comes, and in milling, first of all, you should understand the type of milling. Got it? The type of milling, you should understand the name of the milling. There should be a two type of milling. One you can say a conventional and the other is climb, right? The other name of conventional milling is what? Up milling, or the other name of climb milling is what? Down milling. Now, one by one I am going to show you. Look, this is the conventional milling, right? This is what, my dear? This is the conventional milling. Here you can see conventional milling, the other name is what? Up milling, right? So, I am writing here, I am writing down the other name, I am writing down the other name, conventional milling plus your up milling, right? Conventional milling plus your here up milling will be the other name, up milling. So, you should remember the name of the, you should remember, okay, you should remember the name of milling, conventional milling or up milling. Is that clear? Now, what happened? You can see in conventional milling or in up milling, the milling cutter will rotate in such a way so that the workpiece is going to cut by the teeth and teeth will move from down to upward direction. From down to upward direction. My dear student, here, this is the machined surface, right? This is what? This is a machined surface. Okay, this is a machined surface, right? This is a machined surface. As you can see, this is what? This is a machined surface. So, here the milling cutter will move from the machined surface to upward direction. And here you can see the chip. Here you can see as the milling cutter teeth moves from down to upward direction, the chip thickness is what? The chip thickness is what? Increases. Look here. This is the uncut chip. That uncut chip is what? Increases when you go from down to up. Okay. And here workpiece will move in this direction, means they will move in opposite direction. Suppose that if you take a tangential velocity, okay, if the milling cutter is rotating in this direction, if I will take a tangential velocity, then the tangential velocity of the milling cutter in this direction and the workpiece is moving in this direction. They are what? They are in opposite direction. Am I clear? Am I clear? Is that the conventional or up milling is clear? Tell me one thing. Is that the conventional or up milling is up milling is clear? Tell me, my dear student. Tell me. Milling cutter will rotate about its axis. Only the workpiece will move on the work table. Only the workpiece will move on the work table. This is a work table, my dear. This is what? This is a work table. Can you ever think how a work table will move a linear motion? Have you ever think how a work table will move, how a work table will do a linear motion? Basically, what happened? Below the work table, there will be a nut. Okay, there will be what? There will be a nut. This is nut, my dear. And In the nut, there will be a lead screw. This is a lead screw. Okay. This is what? This is a lead screw. Got it? This is lead screw. This is lead screw, lead screw, lead screw. This is lead screw, right? This is what? This is lead screw. Now, lead screw will get a power from the power source and it will rotate, right? It will rotate. When the lead screw will rotate, then what happen? The nut will do a linear motion. And above the nut, there is a work table. Work table will do a linear motion and workpiece will do a linear motion. The milling cutter will rotate about its axis. Am I clear? Am I clear? Is that diagram is crystal clear? So, do you understand about the conventional up milling? Okay, now the next is your climb milling. The next is your climb milling, and the other name of climb milling is what? Down milling, my dear. The other name of climb milling is what? The other name of climb milling is what? Down milling. Down milling. Right. The other name of climb milling is what? Down milling. Right. Now you can see here the workpiece is moving in this direction. Okay. And the milling cutter is rotating in this direction, means the rotation. If you take a tangential velocity of the milling cutter and if you take the velocity of the workpiece, they are in what? They are in same direction. Here you can see, my dear student, this is the finished workpiece. This is a machined surface. This is a machine. This is a machined surface which is produced. This is a machined surface which is produced. This is a machine surface, my dear, machine surface which is produced due to machining operation, and this is the initial workpiece. So here you can see the milling cutter is rotating in such a way, so the material will cut. So the material will cut. See properly here, please. Material will cut from the initial surface. Okay, from the initial surface, and when you go in the downward direction, my dear student, when you go in the downward direction, when you go in the downward direction, right? When you go in the downward direction, then what happened? Look, then the thickness of the, look, this is the uncut chip thickness. This is what, my dear student? This is the uncut chip thickness, my dear. This is the uncut chip thickness. When you go in the downward direction, that uncut chip thickness goes to decreases, and at the end, you see please, and at the end, the uncut thickness of the removed chip is minimum. The uncut thickness of the uncut thickness of the removed chip is what? Is minimum. Am I clear? Am I clear? Tell me yes or no. Please tell me yes or no. Is that point is clear to you? Is that point is clear to you? Is that point is clear to you? Tell me yes or no, please. Climb milling or down milling is clear? Tell me, climb milling or down milling is clear or not? Tell me please. Clear? Okay. Now, now I will tell you something. You know, you can see there are number of teeth. Teeth number 1, teeth number 2, teeth number 3, teeth number 4, teeth number 5, teeth number 6, teeth number 7 and teeth number 8. Right? Right? Suppose that when this teeth number 4 comes in a contact with the workpiece, then it will remove some material from the workpiece, and that thing is known as feed per tooth. My dear, that thing is known as feed per tooth. Okay, this is feed per tooth, right? Feed per tooth is represented by FZ. Got it? Represented by FZ 0.1 mm. Let's say I am taking a unit, because I am directly jump on some numerical portion, because in your gate direct numerical will become. So first of all, I am going to cover some numerical portion. Then after I will discuss some theoretical portion. Okay, so that you will feel some interest in the milling operation. Now, what I say, when this teeth number 4 will comes in a contact with the workpiece, then the teeth will remove that much material. Then the teeth will remove that much material. Let's say teeth will remove 0.1 mm per revolution per tooth. Okay, or you can say that the teeth, whether you talk about the up milling, okay, whether you talk about the climb milling or whether you talk about the conventional milling, the feet per tooth concept is similar, right? The feet per tooth concept is similar. Suppose that when the teeth comes in the contact with the workpiece and when the teeth moves along the workpiece, okay, along the workpiece, let's say 0.1 mm, right? My dear student, suppose that if the number of teeth represented by Z, let's say in a milling cutter, if the number of teeth is 10, then in one revolution 10 teeth comes in a contact with the workpiece, and every teeth along with the every teeth, the workpiece will move 0.1 mm in forward direction. So in a one revolution, tell me the answer. If the milling cutter do a one revolution, then how much distance the work table, then how much distance the workpiece will move? Tell me. It is what? It is 0.1 into 10 means it comes 1 mm, means when one revolution is going to be complete. So 1 mm per revolution. Am I clear? Am I clear? Yes or no? Am I clear? Yes or no? Is that point is clear? Feet? Is that point is clear? Very good, very good. That is the feet basically. It is feet per tooth and it is feet. Okay, it is feet per tooth and it is feet. Now, what is the velocity of the work table? Suppose that if the RPM is n, then you have to multiply. You have to find the velocity of table. You have to find out velocity. Okay, velocity of table. You have to find out velocity of table. That is what? Feed into n. Right, feed into n. So in journal, feed is what? 1 mm into RPM. In journal, you can write that Fz, number of teeth is Zf. So velocity or feed equal to what? You can write in terms of what? Fz. Basically, what is your feed? Feed is your Fz into Z. That is 1 mm per revolution. Now, what is velocity or speed? That is Fz into Z into RPM. Okay, that is a velocity of table, my dear. So please remember this formula, because in GATE exam, 1 mark questions comes from this formula. Am I clear? Am I clear? Because from GATE exam, 1 mark question will become from this formula, that the velocity of the table equal to Fz into Z into N. Am I clear? Is that formula is clear to you people? Tell me yes or no. First of all, tell me yes or no. Is that formula is clear to you people? Tell me yes or no. First of all, please. Clear? Clear? Okay. Now there are generally there are various type of milling. But because I have to deal some question, so I am introducing 2 type of milling. First of all, that is peripheral milling or face milling, right? Peripheral milling or face milling. So how a peripheral milling will be look like? Look, this is a peripheral milling, right? This is what? This is a peripheral milling, right? This is a peripheral milling. How a peripheral milling will look like? My dear student, if the drill axis, right, if the milling cutter axis is parallel, sir, that means feed equal to Fz Fz into Z. No, Chamankant. What do you mean? I don't know. Yeah, feed. Yes, feed. Yeah, feed. Feed is what? Fz into Z. Right. And speed is what? Fz into Z into N. Because Fz into Z is what? F. Clear, Chamankant? Chamankant, is that clear? Yes, Chamankant, tell me, is that clear? Now, so, what I am telling you, one is your peripheral cutting. Okay, peripheral milling. Peripheral milling. In peripheral milling, see, this is the milling cutter, okay, and here you can see this surface. This surface is what? Machine surface. Machine surface, my dear. See, this surface is what? Machine surface. In peripheral milling, you can see the milling cutter axis is parallel to what? Parallel to what? Machine surface. Right? Here also, this is the milling cutter axis. This is the milling cutter axis. This is what, my dear? This is the machine surface. Here also, the milling cutter axis is parallel to what? Parallel to machine surface. So that's why generally we call it as what? It is a peripheral milling. Am I clear? Am I clear? Tell me, am I clear? Is that peripheral milling is clear? Tell me first of all, is that peripheral milling is clear? Now the next milling is face milling. Right, the next milling is face milling. Let me show you the face milling. My dear, this is a face milling. I hope you are able to see this diagram. This is a face milling. Face milling is a milling where the milling cutter axis, this is a milling cutter axis, right? This is a milling cutter axis, and here you can say this thing is what? The machine surface. Here you can see the milling cutter axis is perpendicular to what? Machine surface. Again see, again please see, this is a milling cutter axis. Here the milling cutter axis is perpendicular. This is what, my dear? This is the machine surface. Please see, this is what? This is the machine surface, right? This is what? This is machine surface, right? Machine surface. So here also you can see the milling cutter axis is perpendicular to machine surface. So in face milling, the milling cutter axis is perpendicular to machine surface. Here also you can see this is the milling cutter axis and it is what? This is a machine surface. Again you see machine surface. Am I clear, my dear? Am I clear? Is that point is clear? Tell me. The face milling and peripheral milling is clear. First of all, please let me know the face milling or a peripheral milling is clear or not. Tell me, face milling or peripheral milling is clear. Now I am going to jump on the numerical. Right. I am going to jump on a numerical. Then I will discuss the gang milling. I will discuss straddle milling. I will discuss form milling cutter. I will discuss, okay, form milling cutter and various type of other milling also. So before that, I want to discuss the important part which comes in your GATE exam. Right. As you know, the milling cutter is rotating. Okay, if the milling cutter is rotating, okay, if the milling cutter having a diameter D, this is my milling cutter, it has a diameter D and it is rotating with the RPM N. This is a milling cutter, it is rotating with the RPM N. Okay, so at the periphery, you know there will be a teeth, at the periphery there will be a teeth, at the periphery there will be a teeth, at the periphery there will be a teeth. And teeth will cut the workpiece. Now, with what velocity the milling cutter will cut the workpiece? If the milling cutter will rotate, having a diameter D, having a RPM N, then the cutting velocity, peripheral cutting velocity means this, or either you can say this, or either you can say this, or either you can say this. Then the peripheral cutting velocity is what? Then the cutting velocity is what? pi d n divide by 1000, because here the diameter is in mm. If the diameter is in mm and r is in revolution per minute, then the velocity will become meter per minute. Am I clear? Is that point is clear? My dear student, is that point is clear? Tell me yes or no, please. Tell me yes or no. Is that point is clear? Yes or no? Is that point is clear, my dear student? Okay. Now, the famous question in milling, okay, the famous question in milling is what? Machining time. The machining time. You have to tell me the machining time, okay, what should be the machining time in the milling? That will be the numerical question. That will be the numerical question, okay, that will be a numerical question which comes into your GATE exam. So whatever I am dealing here according to your GATE exam, right? Whatever be the topics which are important for your GATE exam, that topics I am discussing here in your crash course. So again, the machining time comes in a picture. So what should be the machining time? Let's say, please now give your proper focus, give your proper attention. Now we are discussing a very important part, okay? We are discussing a very important part. The first, that is peripheral milling. Peripheral milling. In peripheral milling, what should be the machining time? Right? What should be the machining time? Let's say, my dear student, there will be a milling cutter which will be rotate, okay? There will be a milling cutter which will be rotate. This is a milling cutter, let's say. Okay, let's say this is a milling cutter which is rotating about its axis. Let's say this is the milling cutter which is rotating about its axis. So here I am drawing a milling cutter. This is a milling cutter and it is rotating about its axis. Now, my dear, there is a workpiece. Let's say there is a workpiece which is in a contact, which is going to be what? Which is going to be milled. Now, as you know, the milling cutter, whether I am talking about the conventional and down, it doesn't matter. Okay, here it doesn't matter because we are calculating the machining time. Now, milling cutter is rotating and the workpiece will go toward the milling cutter, right? Now, you have to cut that much thickness. You have to cut, my dear, that much thickness. So, that much thickness is what? It means it is what? It is the depth of cut. Yes or no? This is what, my dear? This is the depth of cut. So, it is what? It is D, depth of cut. So, D is what? Here, depth of cut. Depth of cut. Am I clear? This is depth of cut. Now, my dear, here the length of the workpiece, let's say this is the length of the workpiece, which is the length of the workpiece is what? L. The length of the workpiece is L, or I can write L1, whatever he is taking. I will take L. This is the length of the workpiece. Now, when the workpiece, here the workpiece is in the contact with the milling cutter, right? When the workpiece will move toward the milling cutter, let's say the workpiece will move here L length, okay? Now, let me draw the figure completely. Figure should be proper. I am drawing a proper figure here so that you will understand the concept in a very well manner, right? You will understand the concept in very well manner. Look, this is again I am drawing a milling cutter. See, now here the workpiece will reach, my dear. Here the workpiece will reach. Look, this is the L workpiece, okay, and here the workpiece. Look, this is a broken line, my dear. This is what? This is what, my dear? This is the broken line which I have drawn. Please try to understand. This is the broken line which I have drawn here. Okay, this is the broken line. Not this one, this one, this one. See. Is it visible to you? Tell me yes or no. Otherwise, I will draw again. Because here the visualization is very important, my dear. Here the visualization is very important. That's why I'm asking you. Again, I'm trying to draw in a bigger figure, so that you will understand. See, this is a dotted line which I have drawn, right? This is a dotted line which I have drawn here. Look. So, because I am drawing a proper figure, that's why it will take a time. Now, is that the broken line is visible? Is that the broken line is visible? Okay. If it is not visible, then I am just remove. I am going to just remove. Right, I am going to just remove. Yes. Look, this is a scenario. Basically this is a scenario. Now tell me, is that the complete milling is the milling is completed? Tell me, is that the milling is completed? Yes or no? Tell me. Here the workpiece will move. Here the workpiece will move L length. Here the workpiece will move L length, my dear student. See, is that the milling is completed? Yes or no? Yes, tell me. Here, this is the workpiece, it is moving. Now, suppose that it will comes here. As you can see, the milling is not completed yet. The milling is not completed yet. Right. Here, the cutter has to move that much distance. See, the cutter has to move that much distance. Yes or no? The cutter has to move, my dear, that much distance. See, this is the basically this is the machine surface, right? Now the cutter has to move that much distance. So what is the value of that much distance? We have to find. Okay, we have to find that distance, my dear, is known as what? Approach A. That distance is known as A. Let's say, so milling cutter has to move A length. Then after the cutting will take place. Am I clear or not? Am I clear or not? After completing L length, because here the milling cutter is completed the L length, here the workpiece will travel the L length. After that, the workpiece has to travel extra distance. What is that? That is A. Am I clear? Yes or no? Tell me, those who are not understanding why A, then please let me know. Then after I will explain. Is that clear? Is that clear? The A concept is clear. The workpiece, the work table has to move. The work table has to move A length. Then after the machining will be completed. Yes or no? Tell me. Now, what is the value of A? Very simple. By geometry you can find out. By geometry you can find out. How can you find out? This is what? This is D by 2, my dear. Right. This is what? D by 2. And this is what? This is what? This is D by 2 minus depth of cut. So, we can find out the A. We can find out the A. How can we find out the A? See, you can find out the A. See, here A. Let me write down the A, about A. So, I can find out the A also. A is what? A is root of D by 2 whole square minus D by 2 minus small d square. Yes or no? Yes or no? This is a. Now, how can the exact value of A is what? That is root of D by 2 whole square minus D by 2 whole square plus D square minus small d capital D. Am I clear? Now, once you open, then this will be cancelled, minus plus. So, here it will becomes D capital D minus small d. This is what? This is the approach distance. Am I clear? Yes or no? Tell me. Am I clear? This is what the A, that distance workpiece, work table has to move. Now, suppose that if the, okay, suppose that if this is a milling cutter, let's say again I am drawing here. Now, if the work table has moved the A distance, right? If the work table has moved, let's say the A distance, okay? Let's say the A distance. Now, see properly, okay? See properly, my dear student, see properly. Look, now the milling is completed, yes or no? The milling is completed. Here, this is the broken line which I am showing you. Basically, you cut. This is the broken line which I am showing you. This is the broken line, my dear student. This is the broken line. Okay. This is a broken line. Broken line means what? That much material you removed. That much material you removed. Am I clear? So here the milling cutter. See here the milling cutter spot. See here the milling cutter teeth is present right now at the corner of workpiece. Milling cutter teeth is present at the corner of workpiece. My dear, here the cutting is completed, but there is a chance, that the cutter teeth will damage the corner surface. Yes or no? There is a chance that the cutter will damage the corner surface. Tell me yes or no. Tell me yes or no. Arey Baba, tell me yes or no. There is a chance na? There will be a chance na that the cutter will damage the corner surface of the workpiece. Tell me Baba, yes or no. Arey tell me yes or no. There is a chance that the teeth will damage the corner of the workpiece. Yes or no? So we have to travel the workpiece further. Okay, by how much distance? If for a safety, you know, this is the center of the milling cutter. Okay, this is the center of the milling cutter. Let me draw again. This is the center of the milling cutter. This is the center of the milling cutter, as you know. And this is what, my dear? This is what? This is, yes. You know, this distance, my dear. You know this distance. This distance is what? This distance is what? A. This distance is what? A. Yes or no? This distance is what? A. This distance is A. So equally, you have to move workpiece in such a manner so the milling cutter completely out of the workpiece, completely crosses the workpiece. Okay, now what to do? Move the workpiece in such a manner so that what happened? Shall I draw here? Okay, I am making little bit small. Okay, I am making little bit small and I am drawing here. My dear, I am drawing here. Please try to understand here. Okay, please try to understand. I am drawing here. Now, milling cutter should be moved in such a manner so that look here, this is a workpiece. Now, my dear, now see the magic. Okay, this is the dotted line, means that much material we have removed. This is a dotted line, means that much material we have removed. Now here, okay, before that I will draw the milling cutter because I am drawing. See, this is a milling cutter here. Now see, my dear, see. Okay, now see. See, the dotted line means, the meaning of dotted line, that much material you remove. Initially the milling cutter was there. Now this point comes here. And here there is no material. The dotted line means that much material you remove, my dear. that much material you remove. Am I clear or not? See, that much material you remove. Okay, that much material you remove. This is what? This is a depth of cut na. So that much material you remove. Now, here you can see the milling cutter is not going to touch the corner of the workpiece. Now the workpiece is safe. So the total machining length is what, my dear? In a peripheral milling, total machining length is what? Total machining length is what? L plus A. L plus A. Okay, here L. Look, here the work table move L, then it move A, then plus A, then plus A. Is that clear? Tell me yes or no. Are Baba, tell me yes or no. Is that point is clear? Is that point is clear? This is a compulsory. This is a compulsory distance. Okay. This must be a compulsory basically. This must be a compulsory length. Compulsory length for machining. For machining. Okay. This is a compulsory length for machining. And here this extra A is what? Over travel. Basically it is what? Over travel. This extra A comes here for the over travel, so the milling cutter teeth will not touch the corner of the workpiece. Am I clear? Am I clear? Yes or no? Tell me. Tell me. Tell me. Please tell me yes or no. Am I clear? Yes or no? Tell me, my dear student. Tell me. Tell me. This is here the machining is completed. Here the machining is completed. Here the travel distance is what? Here the travel distance is L plus A. But there is a chance that the corner of this last teeth will damage the corner part of the workpiece. So we have moved the workpiece in such a manner. Now here the milling cutter is not touching the workpiece anywhere. So here the total length is what? Here the total length become what? L plus A plus A. Am I clear? Am I clear? Now here twist comes. Here twist comes. My dear, here twist comes. Sometime what happen now? Sometime what happen? As you know, total length is what? L. Total machining length L plus A plus A. Okay. My dear, this is a compulsory length as I told you. My dear, this is what? This is a compulsory length for the machining, right? This is a compulsory length for machining. This is compulsory length for machining. Right? For machining. Now, this is a over travel. This is what? Over travel. Over travel distance. Over travel distance. Over travel distance. Basically, over travel distance. And why I have taken A as a over travel? Suppose if in the exam, suppose let, okay, please be focused. Note 1, there is an important note. Note 1, what is the note? In question, if over travel is not given, if over travel is not given, then take over travel distance A. When in the question over travel distance is not given, then take A. Note 2. Okay, note 2. In question, if over travel distance is given, let's say over travel distance is what? Let's say over travel distance is given by X. Then the total length will be what? L plus A is a compulsory. L plus A is a compulsory. Okay, here over travel distance is x. What should be the total length in that case? L plus A is compulsory, and if in the question over travel distance is not given, then add A. Am I clear? My dear student, am I clear? Am I clear? Arey, tell me yaar, am I clear or not? Am I clear or not? Yes or no? Tell me. Yes or no? Right. One more note. One more note. Note 3. If clearance at the entrance and at the exit, okay, or if clearance is given, if clearance is given, okay, clearance is given by, let's say, y, by y, let's say by y clearance is given, and over travel distance is given by, okay, let's say x. So the total length is what? Clearance at the entry, or I will move that, not clearance, approach length. If suppose that there is a approach length, okay, will be approach. If approach length at the entry, if the approach length at the entry is given by let's say y, okay, approach means what? There is a gap in between what? In between milling cutter and what? There is workpiece, right? Approach means what, my dear? This is the workpiece and there is a milling cutter. Now you can see there is a distance now. In between. This is the distance, and this is given by y, right? Then the total length is what? L. The total length is what, my dear? Okay, this is what? This is y. The total length is what? First of all, table will move y distance, then milling cutter will touch the workpiece, then table will move L length, then A. Now, here in the question, over travel distance is given by x. So I will add x, not A. Is that clear? Is that clear? Is that clear? Is that clear? Yes or no? Yes or no? And suppose if approach length is given, if the approach length at the entry is given by y, or over travel distance is not given. If over travel distance is not given, then you can take what? A. Beta, if the approach length means what? Milling cutter has to travel or workpiece has to travel that much distance first na. If there is a gap in between workpiece and milling cutter initially, then the workpiece will travel y length na, y. Then after the milling cutter will comes in a contact with the workpiece, okay, then the machining will happen, and you know this is a compulsory length for machining, If over travel distance is given by x, then you add x. Simple. Chamankant, got it? Chamankant, got it? Yes, Chamankant, got it or not? Yes or no? Yes or no? Chamankant. Okay. Clear? Now I will show you the question, but before that I have to tell some more thing. Now you have seen in both the milling, okay, whether you do whatever type of milling, the uncut chip thickness, this is the uncut chip thickness, remember, this is what? This is the uncut chip thickness. Yes or no? Remember or not? Tell me. Now I am going to make it little bit small. I make a workpiece. Look, look, see, is it visible? You have seen in both the milling, this is the uncut chip thickness now. Here you can see the uncut chip thickness. Here you can see the uncut chip thickness is maximum at that end and it is minimum at that end. Okay, T naught uncut, T naught means what? Uncut chip thickness. Okay, minimum at this side, that is almost 0, and here uncut chip thickness is maximum at that point. So what will be the maximum uncut chip thickness, my dear? What will be the maximum uncut chip thickness? The maximum uncut chip thickness is basically the maximum uncut chip thickness. Forget this formula. Twice of Fz root of small d by capital D. Fz is what? Feet per tooth. Root of small d is what? Depth of cut, divided by capital D is what? Diameter of the milling cutter. Now average uncut chip thickness, T naught average. T naught average is what? Basically T naught minimum plus T naught maximum, okay, divide by 2. So 0 plus T max. T max is what? 2 Fz root of small d by capital D. If you add and take an average, it will become Fz root of small d by capital D. Am I clear? Am I clear? Yes or no? Am I clear? Beta, yes or no? Am I clear? Yes or no? Tell me, Baba, am I clear? Yes or no? Simple. Am I clear? Yes or no? Is that clear? Tell me, so that we can do one numerical. Okay. Now, I am going to start one numerical. Okay. See, it is a simple numerical. Then after I will do a difficult one. Okay. Then after I will do a difficult one. Look. A steel flat surface of dimension 100 cross 250 mm is to be produced on a horizontal axis milling. Beta, horizontal axis milling means what? The milling cutter axis is parallel to horizontal axis milling machine, means the milling cutter axis is horizontal parallel to the machine surface, means it is a peripheral milling, An HSS slab mill with a 100 mm diameter and 150 mm width is to be used for the purpose. The milling cutter has 8 teeth. Calculate the machining time assuming that the entire stock can be removed in one depth of 2 mm. Given feed is given 0.12 mm per tooth, cutting speed is given. Is that clear? Now, the entire stock is removed in one stock. So, how a workpiece should be look like, my dear? Okay, the surface on which the milling is going to be happen, the cross section area of that surface is 100 cos 250. So here the scenario is what? I think this is the scenario. Please try to understand. This is the scenario. What I am thinking, this is the scenario. I think this is a scenario. Okay, this one will be the scenario. Look, here you can see this is a surface. Okay, this is what? This is a surface. This is what? 100. This is what? 100. And this is what? This is what? 250, my dear. This is what? 250. right? Now the milling cutter width is what? The milling cutter width is 150. You are removing all the material in one stroke. So it is necessary that the milling cutter should be wider than the width of the workpiece. Then it is possible, okay, then it is possible that in one stroke the material is going to be what? Removed. The material is going to be what? Removed. The material is going to be what? Removed. Am I clear? Yes or no? Tell me. Am I clear? Yes or no? Tell me, my dear. This is, my dear, this is a milling cutter, okay, whose width is greater than the width of the workpiece. Then after, a milling cutter will remove the material from the workpiece in one stroke. Tell me yes or no. Is that point is clear? Is that point is clear? This is a visualization. Got it? Yes or no? Tell me. Yes or no? Tell me. Tell me. This is a width, and the width is what? This is a width, that is 150 mm width, and this is what? This is a dia. You know the dia? This is what? This is the dia, right? This is the dia. Okay, and the dia is what? And the dia is what? Dia is 100 mm. Now tell me. Tell me, Baba, is that clear or not? Tell me, is that clear or not? Yes or no? Yes or no? Is that clear or not? Hello everybody, is that clear now? So basically it's a peripheral milling because the milling axis is parallel to the machine surface. Horizontal axis milling means milling cutter axis is parallel to the machine surface. Now you have to time the machining time. So you know that the total machining length is what? Here the approach length is not given now. Here, my dear, the approach length is not given. So I am not going to add that clearance. The compulsory machining length is what? L plus A. The compulsory machining length is what? L plus A. My dear, in that question, over travel distance is not given. In that question, over travel distance is not given. So what to do? If over travel distance is not given, then you have to add A. So the total machining length become what? So the total machining length become what? L plus 2A. Right? L plus 2A. Now you have to find A. Okay, capital A. So capital A, you know, root of small d, capital D minus small d. So what it comes? What it comes? Now I'm going to calculate it. It comes root of capital D is 100. Depth of cut is 2, answer into 2, root of answer, it comes 14 mm. So the machining length, the total machining length is, okay, the length is what? 250. So 250 plus twice of A, answer into 2, that is 28, because A is 14, twice of A is 28. Answer plus 250, 278 mm. Tell me, is that clear? Is that clear to everybody? Is that clear to everybody? Is that clear? Now, you know that the machining time is what? Machining time is total length divided by table speed now. Divide by table speed now. Total length divided by table speed. Table speed, yes or no? Yes or no? Total length divided by table speed. Tell me yes or no? Tell table speed. Yes or no? Table speed is what? Basically I am representing table speed by small v. So you know table speed is what? Fz into Z into what? Into what? RPM. Into what? RPM. Yes or no? Tell me, is that clear? I'm explaining step by step. I'm explaining step by step. Tell me yes or no. Is that clear or not? This is a table speed now. Tell me everybody, is that clear? Now, do you know the V? Yes. Here feed per tooth is given. This is FZ, my dear. 0.13 mm per tooth. This is FZ. How many number of teeth? Is that number of teeth is given? Yes, number of teeth is given, that is Z is given, but RPM is not given. So how can you find the RPM? RPM is not given. You know cutting velocity, V, pi T N divide by 1000. And cutting velocity is given, that is 20 meter per minute, right? 20 meter per minute, 20. So pi D, diameter of the milling cutter is 100, RPM N divide by what? Divide by 1000 equal to 20. So here comes the RPM, 20 into 1000, answer divide by shift pi into 100. So it comes 63. Okay, it comes 63.6619 revolution per minute, my dear. Right. So here comes the table speed V, that is Fz into Z into RPM. Fz is 0.13 mm. Look, what is mm per tooth? Mm per tooth. And how many number of tooth? 8 tooth. And RPM is given 63.6619 revolution. Okay, revolution. Okay, got it, per minute. So here the table speed will become answer into 8 into 0.13. Answer into 8, yes. So it comes 66.208 mm per minute. Am I clear? Yes or no? Am I clear? Yes or no? Tell me. Am I clear? Am I clear? Yes or no? So this is a cutting velocity, table velocity. Now machining time is what? The machining time is the total length 278 mm divide by, okay, divide by 66.208, okay, mm per minute. So here 278 divide by answer. Yes, the answer is 4.198 minute. This is a machining time. Tell me yes or no. Is that concept is clear? Is that concept is clear? Is that concept is clear? Yes or no? Is that concept is clear? Yes or no? Now, sometime what happen in a question now? Sometime what happen in a question, it is not mentioned which type of milling, peripheral or phase. You take a peripheral milling, don't worry. Now, here the next question of GATE 2012 PI comes in front of you, my dear, comes in front of you. Okay, so let's solve this question. Let's solve this question. In this data, plane milling operation are given, length of the workpiece means L is given, cutter diameter is given, number of teeth, that is Z is given, cutter speed means RPM is given, feed 200 mm per minute, okay, feed 200 mm per minute means this is a V, depth of cut D is given, the total clearance entry and exit 5 mm, you have to find mean undeformed chip thickness in micron means you have to find T naught average, mean is what? Average. So what is that? It is Fz root of small d by capital D. Okay, small d is given 2 mm, capital D is given 100, but Fz is not given. You know that feed equal to table feed or velocity equal to Fz into Z into RPM, right? Number of teeth is what? 4. So V equal to what? 200, okay, mm per minute. Fz is what? Fz you have to find out. Z is what? 4 into RPM is what? 100. Okay, so here Fz will become 0.5 mm per tooth. Now put here T naught average. Put here 0.5 root of small d, that is 2, divide by 100. It will becomes in mm. In microns, it will becomes nearby 71. You can find out you can find out root of 2 divided by 100. Answer into 0.5. Yes, it is coming 0.07071 mm. In microns, it will becomes 71 microns. Am I clear? Am I clear, my dear student? Am I clear? Yes, am I clear? Tell me, Baba, am I clear or not? Clear na? Clear na? Yes or no? The concept is clear na? Now, the next part of that question. The next part of the question. Okay. You have to find the machining time. You have to find the machining time. Okay. The machining time for a single pass in second. My dear, here, this is the length of the workpiece is given. Cutter diameter, okay, D is given. Number of teeth, okay, 4 is given. Cutter speed is given. RPM is given. Okay. Feed is given. Okay. This is the main thing which we need for the cutting, for the machining time. Sir, I want to assess. I want to ask. Yes, ask Neha Moria. Ask Neha, what do you want to ask? You want to ask? I mean, your complete sentence should be, sir, I want to assess means you want to ask something. So please ask so that I can move further. I can move further. Meanwhile, please solve this question. Meanwhile, please solve this question. Oh, you want to take a screenshot? Neha, no need to take a screenshot. I will provide all the PDF. Neha, I will provide all the PDF on my Telegram group. On my Telegram group. Okay. But still, if you want to, I will provide all the notes. I will provide all the notes on my Telegram group. But still, if you want to take the screenshot, you can take. But I will provide whole PDF on my Telegram group. And my Telegram group, as you know, Aditya Pal Gate Academy. You can search my Telegram group, Aditya Pal Gate Academy. Okay, you will get my Telegram group. On that Telegram group, you will get all the notes, right? Daily notes. Got it? This is the advantage. Now, please solve this question. Look, here you want to know, you want to calculate the machining time. What is the machining time? Total length divided by table speed or feed. Now, what is the table, what is the total length? My dear, please listen me carefully. Please listen me. Here the total clearance means entry and exit. At entry, he has given some clearance. Please listen to carefully. At entry, he is providing some what? Some clearance. See, he is providing some clearance. Let's say it is Y. Let's say it is Y. Right, let's say it is Y. And at the exit, my dear, exit means what? Exit means entry. Entry and exit is what? Exit is a over travel. Okay, entry is Y and exit is what? X. Tell me. Here he provide total clearance. Entry plus exit. End means what? In English, end means plus. Okay. Entry and exit. Entry means entry plus exit. Distance is what? 5. So at entry he provides some clearance, that is Y. At exit he provides some distance. After cutting at exit, he provides some distance, that is X. Means it is over travel. Means it is a over travel. Got it? So the total length is what? X. Okay, total length is what? Total length is what? Y plus, okay, first of all milling cutter will reach here. Then the compulsory length for machining of the workpiece L plus A. Now, he is saying at the exit, he is providing, means he is mentioning the over travel distance. So, it is what? It is X. But entry and exit is what? Total is 5. Means here X plus Y is what? Here X plus Y is 5. L plus A plus X plus Y. Total. He is using total. Means X plus Y equal to what? 5. So L is what? Length of the workpiece is 200. Right. Plus A. Root of what? Plus A. Root of what? D. Depth of cut. What is the depth of cut? 2. 100 minus 2 plus X plus Y, 5. Am I clear? So 200 plus, it comes 14 plus 5. Okay, yes or no? Tell me. So 200 plus 14 plus 5. Total distance is what? 219 mm. Now the machining time is what? Machining time is what? 219 mm divided by 200 mm per minute. Answer divided by 200, answer into 60, because he is asking answer in seconds. So the answer will be 65.7 second. So nearby option is what? B. Is that clear? Nearby the option is what? B. Tell me yes or no. Tell me my dear. Tell me my dear, yes or no. Is that clear? Is that clear? Tell me Baba, is that clear or not? Tell me, is that clear? Yes or no? Now, the last concept is face milling. The last concept is face milling. Look, face milling. Face milling. You know, in face milling, basically this is your workpiece and this is the milling cutter. Here the milling cutter axis is what? Perpendicular to the machine surface, right? So if you draw a top view, it will be look like this. It will be look like this. Draw a top view. So draw a top view. Okay. Now draw a top view here. Suppose that this is my milling cutter here. First of all, I will draw a milling cutter. This is a milling cutter. And here I am assuming that my milling cutter diameter is wider than the width of the workpiece. Okay, look. Here I am assuming that the milling cutter diameter, okay, this is the diameter of the milling cutter. And I am assuming that the milling cutter diameter is wider than the width of the workpiece. This is what? Width of the workpiece. Am I clear? W is what? Width of the workpiece. Now, suppose that the length of the workpiece is what? L. This is L. This is the length of the workpiece. Now, suppose that, again, you can see there is a milling cutter. Okay, there is a milling cutter. If the workpiece will travel the L length, right? If the workpiece will travel the L length, suppose this is a scenario. Tell me, here the workpiece has traveled the L length, my dear. Here the workpiece has traveled the L length. Tell me, is that the milling is completed? Here the workpiece has traveled the L length, okay, or the work table has traveled the L length. Is that the milling is completed? Yes or no? Is that the milling is completed? Yes or no? Tell me, my dear. I think no, because see, there is some material. See, there is what? There will be some material. See, there will be some what? There will be some material. On symmetrical side, you can see there is what? There is a material. See, there will be some material. So this material has to be cut. Either the workpiece has traveled the L length, but total machining is not completed yet. Why? Because that much distance the milling cutter has to travel. How much? That much distance. Then after the machining will be completed. Let's say this distance is what? Let's say this distance is A. And how much this distance? You can calculate this distance by a geometry. Okay, by a geometry. You know, this is what, my dear? This is D by 2. How can you calculate? You can calculate in very easy manner. This is what? This is D by 2. Okay. See. Oh my God. Yes. See. So, okay. Now, how can you calculate? You know, my dear, this is d by 2 and this is total is w. So, you want to calculate A? You want to calculate A? Okay. Once you calculate that much distance, is that clear? Is that visible, or I will, okay, I am going to make it larger, little bit larger. Now, let's say this is O, this is B, and this point is what? C. Now, you have to calculate this capital A. Once you get the OB, then how can you calculate A? A is what basically? It is d by 2 minus OB. D by 2 minus what? Minus OB. Yes or no? Sir, your explanation, sir, you explain complex topic in very simple way. Thank you. But still I got Bijan Nanda. As you say that I am explaining very complex table in a very complex topic in a very simple way, still I got 2 dislike. Huh? Bijan Nanda, still I got 2 dislike. Either it means what? Either I am explaining very bad, or either I am very famous, so that people are jealous. People are jealous about me. Huh? What do you think? Now, you have to find A. So, how can you calculate A? A will be calculate O. This is what? Let's say OD. Let's say OD. Okay. Let's say here is OD. So, how can you calculate OD? OD minus OB. And what is OD? OD is what? Capital D by 2. Okay. Capital D by 2 minus OB. You have to calculate OB. How can you calculate OB? How can you calculate OB? Okay. Let me see. My dear, I can calculate OB. How? Look. I can calculate OB. OB will be comes out equal to, look, it will be comes out, look, d by 2 square, okay, minus w by 2 square. Yes or no? Tell me. Is that OB? Is that OB? Is that OB now? So this is OB. Look, d by 2 square minus what? BC. BC is what? W by 2 square. So how can you find A? Simple. D by 2 minus root of capital D by 2 square minus W by 2 whole square. Simple. Right? Right? So simple. So the total machining length in that case, L plus A. L plus A. My dear, what happened now? What happened? Suppose that now this is a milling cutter. Now the workpiece will reach here. Now the workpiece will reach here. Okay. So the total distance is what, my dear? Total distance is what? See, this is L length. This is what? This is L length. Right. This is what? This is L length. See, the total distance is what? L plus A. This is the total distance. So the total distance is what basically? This is the total distance basically. This is the total distance. Right. This is the total distance. That is LT. That is L plus A. Am I clear? Now, you will be thinking, sir, we have to over travel the tool. No, my dear. In face milling, generally, the tool will be, okay, move in up and down direction. Once the milling is completed, the little bit it will move along the axis and you can remove the workpiece. So in the face milling, this will be the total length. Right? 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 So my dear student, as the time is not permitting, Already the time is 6:15. So I'm going to provide you my notes. In my notes, you will see the every type of milling. I mean to say, okay, some name are there, so you can see. Some form milling cutter, you can see, okay, a straddle, gang. So you just follow my notes, you will get all the things, right? You will get all the things. The very, very important part I have discussed, which comes in your GATE exam, got it? But some theoretical points are there, like what is a gang milling? I mean, it's very simple. Gang milling is that on the arbor is the basically what? This is a arbor, my dear, arbor. Okay, this is what? Arbor. Arbor means a shaft is there, arbor. On arbor, we mount more than 2 milling cutter and it will do a milling in one pass. We call gang milling. In straddle, on arbor, we mount 2 milling cutter, but we are going to keep some space in between the milling cutter. In between the milling cutter. So that the cutting will not happen in between them. This is called what? This is a straddle milling. So all the name I have mentioned in my notes, you just go through it. They are just random people who are aimed to demotivate the teachers. So please ignore them. Yes, I am ignoring. Now, so all the theoretical points I have mentioned in my notes, you just go through. Okay, you just go through. You will get all the things. Got it? You will get all the things. So okay. So today I am ending this session here. Got it? Today I am ending this session here. We will meet tomorrow, and tomorrow we will discuss remaining machining topics. Remaining machining topics like shaper, planer, slaughter and grinding. Grinding will not come. Basically, from grinding, numerical question will not come. Numerical question will not come from grinding. Some theoretical question will become, and that important thing I will discuss. Along with I will discuss shaper, planer, slaughter. So tomorrow we will discuss shaper, planer, slaughter plus grinding. Okay, my dear student. So thank you for watching this session, and we will meet tomorrow. Thank you.